Yes, a very good morning, everyone. So, in today's class, we are going to discuss regarding the time shifting property of a unit step function. Next, later on, we are going to discuss about the ramp signal. Okay. Next, we are going to discuss about the very well-known impulse function. Okay, we are going to discuss about ramp function, impulse function. Next, the sinusoidal functions if time permit, or else I'll be sending you the study material, sinusoidal signals and the pulse signals. Okay, pulse along with the exponential signals. So these are certainly the type of signals which are rarely used. Okay, so type of signals there. Okay, so now when I talk about one important property, which was the time shifting property of a unit step function, that is u of at minus t naught, which would be equal to u of t minus t naught divided by a. So if you want to use a property where you will be having 2t minus 3, somewhat like this, right? So you will be having such property for a unit step function. You can write it to be u of t minus 3 divided by 2, where a, certainly a here represents 2, which is not equal to 0 there. Okay, so any such properties which are there, you can express it like this. So it is not a problem, and you can make use of certain things. Or for example, you will be having the reflection property also being there, right? So if you want to utilize that reflection property which is there, so you can also use it for a unit step function. Okay, so this unit step function, as I already told you, can anyone define unit step function? Is Bhumik there? Bhumik?
Sir,
Yes. How do you define unit step function mathematically? Is Hemant is there? Hemant? हेमंत है इधर आओ रो. Yeah, so this is the unit step function definition there. So where you will be having the magnitude equal to 1 when t is greater than or equal to 0, that is 1, and 0 elsewhere. Okay, so this is how you can define it mathematically, and you have the time shifting property that is there. Okay, for a unit step function given a constant along with the time, and later on what you can see here is you will be having the shifting nature. Okay, shifting nature is also being expressed in case of a unit step function. Okay, so meanwhile we had solved a few problems related to, that is, the periodicity. Okay, so I'll be giving you certain problems also along with the solutions in the later part of the class, or I will be sending it to you. You can go through it and you can do let me know if you have any queries. Okay, so next one what we are going to discuss is regarding the ramp function. Okay, so as you already know it in the name itself, the ramp function. Okay, so ramp function, how do you generally define it mathematically? So it is given by r of t or r of n. Okay, so that is how you can represent a ramp function. Fine, so mathematically how you can express a ramp function. Okay, so you can express a ramp function as r of t. Okay, r of t, that you can express it as t for t greater than or equal to 0 and 0 elsewhere. Okay, so you can express a ramp function. Okay, so by t, the value of t, what it takes. Okay, so 0, this is 1, this is 2, this is 3, this is 4. Okay, this is t, this is ramp signal that is there, that is a continuous time domain. So you will be having the ramp signal to go like this. At 1, the ramp which will be equal to 1. So once I give 0.5, it is 0.5 here. So you can see. Okay, so you can see at 2 also you can have at 1.5, you Yeah, you can have it. So each and every value that you can take it. So if you take the slope of it, what will be the slope?
1.
Yes, exactly. The slope will be equal to 1. Okay. So the slope of this ramp signal, generally it is a straight line crossing through the origin. So you will be having y is equal to mx plus c as the general equation, where c intercept, that is the y intercept, that will be equal to 0 there. So y, that will be equal to mx, where m will be the slope. General straight line formula, if you can recall, that would be the slope, in which how I can define the slope of the ramp signal. Okay, so this can be expressed mathematically as r of t into t, where t is greater than 0, its magnitude will be t, and its magnitude will be 0 other than t values. Okay, so t greater than 0 with greater than or equal to 0, you are going to have it as t, and it is 0 elsewhere. Okay, so that is one thing that you can observe. Alternatively, how I can write r of t in terms of u of t. Okay, so r of t in terms of u of t, in terms of u of t, how I can write it. Okay, so let me recall what I told you in the previous class, where u of t is a right-handed signal. Okay, right-handed signal rate. Okay, so now its magnitude generally will be equal to 1. Okay, its magnitude will be generally equal to 1. Now, how I can write r of t? Again, it is a right-handed signal. If you can clearly understand, r of t would be a right-handed signal there. So how to write this r of t signal in terms of u of t? As I already told you, it would be t into u of t. So u of t magnitude, if it is equal to 1, so it is just like writing 2 as 2 into 1. Okay, writing any number 99, that would be equal to 99 into 1. Okay, so 99, 1 can be represented as u of t. Okay, so 99 times u of t, where t would be greater than or equal to 0 there. So that's its magnitude. U of t's magnitude will be equal to 1. U of t's magnitude will be equal to 1 there. So I can write this to be t into u of t for t greater than or equal to 0 there. Okay, so and 0 elsewhere, and 0 elsewhere. So this is how I can write the representation of a ramp signal, very important one, representation of a ramp signal by a unit step function. Okay, so that's how I can write it. Now, very important thing, all the time shifting property that is there, which was applicable, holds good for the ramp signal also. Holds good for the ramp signal also. Okay, so that is the basic operations on independent. Sir? Yeah, go ahead.
Sir, in ramp function, it will be a straight line, no, sir?
Yeah.
But if you multiply t into u of t, it will be like a step, no, sir?
Yeah, t into u of t. See, what I mean here is the value of u of t. I'll tell you, that's a good question that you have asked. So u of t is there. So its value will be 1, isn't it? I am talking in specific about unit step function. Okay. So what I mean here is, this is the unit step function that I have written here. Okay. So now at t is equal to 0. Okay, Rahul, you can just look here. So at t is equal to 0, it is 1. Okay, 1 into 0, that will be 0. Okay, at 1 here, so you will be having r of t to be 1 here. Okay, so what is the value at 1 here? That is 1. So 1 into 1, that is 1. Okay, so this is 2. Okay, this value will be 2 here. Okay, so 2 into 1, what would be the value? 2. And therefore 3, that would be 3, 4. You can just have a signal which takes a straight line passing through the origin. Okay, so therefore I can write r of t to be equal to t into u of t only when t it is greater than or equal to 0. Okay, any doubts? That's one of the good observation that he has made. Yes, I have given you the mathematical way of expressing it. If you have any doubts, you can just let me know. I'm doing the multiplication process here. Okay, so R, okay, so u of t would be equal to unity, whatever the t values greater than or equal to 0 that it takes, like other than 0 value, once I take it, so that would be equal to 1. Okay, so this value, sorry, this value which will be equal to 1, and this is the value of t what it takes in the signal there. So that is the ramp signal what is given here. So R of t can be written as t into u of t, that is for t greater than or equal to 0. Okay, as I was mentioning, basic operations on independent variables. Okay, so all these independent variables, whatever the operations that we are performing, okay, the whole thing holds good for the ramp signal also. Okay, yes. Any doubts up to this point? You can just unmute yourself and do let me know. If you have any queries, I would be able to clarify it. Okay, or else we'll move to one simple problem. I think we had done the same problem with respect to the unit step function. So here, in case of a unit step function, we are replacing it by a ramp signal there. Okay, so the question goes this way: sketch the following signals. Sketch the following signals. Say that is x4 or x of t, sorry, that is r of t plus 1 minus r of t, okay, plus r of t minus 2. Okay, so this would be one of the signal, and the next signal I would like to give it as a assignment to Vedant Pandit. Vedant, is it there? Just inform him. So he is going to solve this. Sketch the following signal, that is x of t, that would be equal to r of t plus 2, okay, minus r of t minus 1 plus r of t minus 2. Okay, so this is how you will be getting the problems, and this is one of the important problems that you are going to get it once you have the basic operations being performed on signals there. Okay, so it is quite simple that what we had done in the unit step function, the same thing would be followed here. So let me sketch the signal for r of t plus 1, consequently next r of t, we already know it, next r of t minus 2. Okay, a slight change what I can do here is I'll be writing it in terms of sum itself, that is r of t plus 1 plus minus 1 into r of t, okay, plus r of t minus 2. Okay, so now the first signal what I would like to take is, this is x1 of t, this is x2 of. Okay, so this is how we are going to move ahead. Okay, so first one, that is x1 of t, that is x1 of t. So how I can write it? R of t plus 1. Okay, so what type of signal it is? It is an advanced signal. It is an advanced signal. Okay, so it is moved to the right. Sorry, it is moved to the left there. Okay, so 1 minute. It is moved to the left. It is moved to the left. What I mean here is, so this is R of t signal. Okay, so this is there, and this is minus 1. This is minus 2. Okay, so it starts from here and it starts moving there. Okay, so that's how the signal would look like. This would be for R of t plus 1. Let me sketch as I write. Advanced signal, it is moved to the left by 1 unit. Okay, it is moved to the left by 1 unit. Fine. So next, what I would like to write here is the signal, that is R of t plus 1. Okay, so this is r of t plus 1. So 1, 2, 3, 4. This is minus 1. This is minus 2. Okay, so this is how the signal would look like there. Okay, yes. Okay, so this is how the signal would look like. So this is r of t plus 1. Okay, hope you have understood how did I write it. So r of t, which is being shifted towards the left by 1 unit. So r of t is shifted, okay, towards the left by 1 unit. Okay, towards the left by 1 unit. Okay, next one. So this is x1 of t sketch, what I've written here. Next, what you are going to do is you are going to have the x2 of t. Okay, so as I already told you, this is r of t. Okay, both are entirely different, as I'm going to tell you. So minus 1 is being multiplied. If I want to multiply minus 1, that would be amplitude scaling. So many of you have gone wrong when it comes to writing the assignments. Please be clear, amplitude scaling. Okay, so it would be outside the independent variable. Okay, so minus 1 into r of t. Okay, so minus r of t, that is there. Okay, so that is the problem that you are going to face it in your examination and also in your test. Okay, so see to it that you are going to have the amplitude scaling done properly. Okay, now fine. So amplitude scaling, as I already told you, the slope would be minus 1 there, right? So minus r of t. Okay, this is how the signal would look like for minus r of t. Okay, so this is 1. Okay, this is 0. This is 1. Okay, that would be minus 1. Next, it would be minus 2 here. So I'm just giving you a representation how the signal would look like. Okay, so minus r of t signal, that is t here. Fine. Now x2 of t sketch is done. So it is amplitude scaling. Next one that you have here is r of t minus 2. Okay, r of t minus 2, what it would look like. So r of t minus 2, as I already told you, r of t minus 2, it is a delayed signal. It is a delayed signal. Okay, so when as I already told you, r of t is shifted towards right. Okay, so towards right, to here it starts towards right. Yeah, so this would be the signal for r of t minus 2. Okay, so this would be the signal for r of t minus 2. Okay, so when r of t is shifted towards right by 2 units, r of t minus 2 is obtained. Okay, so this is how you are going to obtain r of t minus 2, which is x3 of t. I've got the sketch of x2 of t, and I've got the sketch of x3 of t. Let me write it here. This is the sketch of x3 of t. Okay, so that's how you are going to get the sketches of 3 signals, that is x1, x2 and x3. Okay, so now carefully, this is minus 1. Let me write it for your convenience. So this is 1, 2 and 3. Okay, so carefully, this is the ramp signal that I'm going to draw here. So if you observe r of t plus 1, I'm giving you a hint. Okay, at minus 1 it is 0. Okay, at minus 1 it is 0. It is like this. Okay, so how can you express it mathematically? X1 of t can be expressed mathematically as t. Okay, t where it starts from where t would be greater than or equal to minus 1. Okay, so t that would be equal to greater than or equal to minus 1 and 0 elsewhere. Okay, so as I proceed from minus 1 to 0, 0 to 1, 1 to 2, 2 to 3, and so on, you are going to get the magnitude that would be equal to the t value. Okay, the time value what you are going to give there. So once it crosses -1, you are going to get its value there. So at 0, certainly it would be 1. Okay, and at 1 it would be 2. Okay, and at 3, okay, it would be, yeah, at 0 it is 1, at 2 it is 3. Okay, if you observe carefully, this is how the signal would look like. Okay, so this is the one. Okay, yeah. Okay, now this is the ramp signal, as I already told you. So there is no end, like as t greater than or equal to 0, the value of t, whatever it takes, that would be the ramp signal. Okay, so let me redraw all the signals at once. Okay, so I want to draw signals. Okay, so that would be -1. Yes, so this is 0, this is 1, this is 2, this is 3. Okay, so this is r of t plus 1. Okay, so this is x1 of t, this is x1 of t, this is t there. Okay, next what to do, that is r of minus, that is minus r of t. Okay, that is minus r of t. Okay, so that would look like this. Okay, yes, fine. Let me drop down for your convenient. Yes, so it would be easy for you to sketch if you drop down at each and every time instant. It would be easy for everyone to sketch. So I request all of you to follow the same procedure what I'm following. Okay, so it would be quite easy for you. If you know it better, that would also be fine. But somewhere in GATE and all, any competitive exams which are there, if you are very good with that, you can go ahead and solve it. But if you are solving it for the first time, I repeat, if you are solving it for the first time, it is better that you go for the approach of dropping down at each and every time instant there. Okay, so this is sorry, this one is x2 of t, as I already told you. Next, this one would be x3 of t, what I'm sketching right now. So x3 of t. Okay, fine. So you are free to talk. If you have any doubts, do let me know. You can stop me at any time. You can just ask me to repeat it n number of times. I would be able to do it. Okay, so next what I would be doing here is, so it would be 2. I'm writing r of t minus 2 signal now. Okay, so r of t minus 2 signal. So how to write r of t minus 2 signal? So this is 0 at 2. Okay, next at 3 it is 1, at 4 it is 2, and so on. So this would be the signal, how it looks like. Okay, don't get confused. So this is the entire different axis, and this one is the r of t minus 2 signal that I have written there. Okay, so this is t and this would be t there. Okay, now we are performing the addition operation, x1 of t plus x2 of t plus x3 of t. Okay, so that would give rise to x of t, that is entirely with respect to the addition of 3 signals that are there. Okay, let me go with a careful representation how I'm going to write here. So at -1 it is 0. So you are going to have no signals at x2 and x3 at -1 to 0 there. So if you observe carefully this time instant, whatever that is there, if you can observe it, it would be a ramp again. Okay, so this would be a ramp again. Fine. So let me draw the x of t signal. The x of t signal starting from -1, 0, this is 1, this is 2, this is 3. Okay, so let me stop at 4, and at 4 you are going to have the same signal that is going to be there. Okay, so let me show you how to write the graph for this addition of signals there. Okay, so let me start from -1 to 0. Okay, that would be again, so at 0 it is 1. Okay, now at 0 it is 0, and again at 0 it is 0. So you are going to have at 0 it is equal to the magnitude what it is equal to is 1. Okay, now here carefully 0 to 1, if you observe it, 0 to 1, okay, this is 1. Okay, so this is the ramp down signal which is there. Okay, at 0 to 1 you are going to have the signal where it cancels out. Okay, at 0 to 1 you're going to have again the signal to cancel out. Next, 1 to 2, I repeat, at 1 to 2, okay, again you are going to cancel out, and the magnitude, if you observe carefully, it is equal to 1. I repeat, so what was the magnitude which was there in r of t plus 1? If you observe carefully, it is 2. Okay, so if you observe, there is a increase in the magnitude as from 1 to 2. Okay, so what I've written in small, that is the increase in the magnitude from 1 to 2. If you observe from 0 to 1, you're going to have the minus 1. Okay, so that is 2 minus 1, that would be equal to 1. That is from 0 to 1. Okay, that is one thing. Next, from 1 to 2, okay, again from 1 to 2 there is a change from 2 to 3. Okay, if you observe the magnitude change, that is from 2 to 3. The final value is 3. What we observed previously was the final value was from 1 to 2. The final value was said to be 2 here. Okay, now this is 1 to 2. Okay, what I'm writing now, this is again minus 2. Okay, this value would be minus 2. 3 minus 2, its value would be 1 again. Okay, now if you observe carefully here, so if I want to find out the slope would be equal to 1. Do you agree to this? Okay, so the slope would be equal to 1. Now what would be the slope? Anyone? Any slope is there here on the straight line, okay, which is parallel to the x-axis? There is no slope. This slope would be equal to 0. Yeah, exactly, the slope would be equal to 0. There is no slant or something like that. If you observe it, a parallel line which is there. Okay, so the slope which is parallel to the x-axis, okay, so that would be equal to 0 there. Fine. Now let me start with 1 to 2 is done. Okay, and again 0 to 1 you have already understood. Now let me start from 2 to 3. Okay, so 2 to 3, so the magnitude here which was from 0 to minus 1, next minus 1 to minus 2, at 3 it is minus 3 for minus r of t. Okay, so this is minus 3, 4 minus 3, okay, 4 minus 3, that is 1, and plus 1. Okay, so that would be 2. So the magnitude here from 2 to 3, it will rise to 2 there. Okay, 2 to 3, it will rise to 2. Okay, so this is 3. Consequently, the operation repeats for 3 to 4 as well. Okay, consequently the operation repeats for 3 to 4, and it is maintained at 2, next 3, and so on. Okay, so that's how you are going to understand it. So you are going to have an increase there. For example, at 4, if you want to write it, what would be the thing? Can anyone tell me? Can anyone unmute themselves and they can tell me if you have understood it properly?
It will be a one-step ramp, sir.
Yeah, one step. What would be the magnitude?
3.
Yes, exactly. What I can show here, I can show an increase in amplitude as 3 here. Okay, if I want to erase this, let me erase this. Yeah, x of t, that would be equal to 3 here. Exactly. So this is how the signal would look like, and definitely the slope of this line would be equal to 1 there. Okay, so that would be the slope, that would be equal to 1. If you have any queries to this problem, because the next problem I've already assigned it to Vedant. If he is there, he can just unmute himself and let me know if he has understood the problem or not, or else we are going to go with the next problem. Is he there, Vedant Pandit? Okay, just convey this message to him. If he has not attending the classes regularly, then no need to come for the online classes from here onwards. Okay, so this is the sketch for x of t, that would be equal to x1 of t plus x2 of t plus x3 of t. Okay, so if you analyze the magnitude, so how to sketch? that is the major thing that is worry here. Okay, so if you analyze at each and every point, that is the starting point. Okay, what I did was I took the starting point and the ending point, I observed it. Okay, so how it is, you are going to have no signal from -1 to 0. You are going to have a ramp itself. So ramp plus 0 0. Okay, 0 plus 0, that would be equal to a ramp again there, right? Now again I did the same thing from 0 to 1. What I observed was the ramp, the magnitude of r of t plus 1 got increased from 1 to 2. Again minus r of t from 0 to -1 there. Okay, so now the r of t minus 2 is not having any such amplitude as of now. That's the reason why you are going to get 2 minus 1, that is 1 again. Okay, so that's how you can get this straight line which is parallel to the y-axis or the time axis there. Okay, so this is how the representation was done at each and every instant of time. Okay, so if anyone who is having any problems in analyzing this problem, do let me know. If you are not understood or if you are finding it difficult, do let me know. Anyone can unmute themselves and do let me know.
Sir, once again explains 2 to 3, sir. The ramp function
Sorry?
is in 2 to 3.
From 2 to 3. Thank you. So at 2, if you observe carefully here, what is the magnitude here? At 2, r of t plus 1. R of t plus 1, what is the magnitude at 2?
Sir, 3.
Yes. At 4? Sorry, at 3, sorry. At 2 it is 3. At 3 it is 4.
4.
Okay. Hope you are clear with this. Next. Now, let me drop down. Minus r of t. Let me come to minus r of t. What is the value at t is equal to 2? Minus r of
Minus-
t ಬಂದಿದ್ದೀವಿ. Minus
Minus
2. Minus 2. Minus r of t ಇರೋದು. Minus 2 ಆಗುತ್ತೆ. ಓಕೆನಾ? Next. Similarly, let me come to r of t minus 2. Okay. What is its value? It is having no value. So it is 3. It is minus 2. 3 minus 2. Okay. 3 minus 2. That is equal to 1 again. Okay. So that's how you can express. So next, again at 3, 4. This is minus 3. 4 minus 3. From 2 to 3 I am talking. 4 minus 3. That is 1. Next you are going to have an increase in ramp as 1. Okay. So this amplitude here represents 1. 4 minus 3 plus 1. That is its amplitude got raised to 2. Next, similarly from 2 to 3. Next, 3 to 4. Okay. So at each and every time instant, if you analyze it properly, you will come to know. So r of t plus 1, r of t with the negative sign in the magnitude, that is minus r of t. Next, r of t minus 2. Okay. So see to it that you are going to practice such problems and you will be able to understand it. Okay. So in case if you have not understood, do let me know. Let me send the solution to this given problem. Okay. Yes. So the next problem goes this way. Just a moment. Yeah. Fine. So this is let him solve it. Okay. Now this one, find and sketch the first derivatives. You have to differentiate only once first derivatives of the following signals. Okay. So that is x of t equals u of t minus u of t minus a, where a is greater than 0. Okay. So now I had to teach a concept here, that is the impulse function. Let me teach it and you can solve this problem. So right now, you just copy down the problem, and meanwhile, I'll be going ahead with a concept called as unit impulse function, and then I'll come to this. Okay, so where a is greater than 0. Okay, so this is one thing that you have to find out, and do make an attempt in solving this problem after getting to know the next type of signal, that is unit impulse function. I think such signals are already done in your network theory, unit impulse function, where you had the Laplacian of unit impulse function to be found. Okay, so meanwhile, a unit impulse function, in the name itself, impulse, it is quite clear, impulse only at a particular instant of time. Okay, so only at an instant where that would be t is equal to 0. Only at t is equal to 0, you are going to have an impulse function like this. So where the arrow represents its magnitude, which is equal to 1. That is delta of t. This is t. So delta of t is the representation for continuous time domain, and delta of n, that is for the discrete time domain there. Okay, so that is mathematically how to express delta of t. That would be equal to, again, the magnitude would be 0 and 1. Okay, so when it is at t is equal to 0, only t is equal to 0 only, and 0 elsewhere. Okay, or I can write it to be t not equal to 0. It is 0 there. Okay, so delta t would be equal to 1, that is at t is equal to 0, and 0 at t does not equal to 0 there. So now if I want to integrate it from minus infinity to plus infinity, okay, minus infinity to plus infinity, delta of t, that would be equal to 1. Okay, so you'll be having zeros here, and again you will be having zeros where t greater than 0 and t less than 0. So at only instant where you will be having t equals 0, you are going to get its magnitude to be equal to unity. Okay, so now can I write like this? Okay, can I write like this? Yeah. So can anyone recall what type of signal it is, what I've written here?
even signal.
Exactly. So it is said to be a even signal. So unit impulse function is an example of a even signal there. Okay. So now if I want to analyze it properly, okay, so this unit impulse function will have a width here. Okay. So this would be the width, that is minus t by 2, and this is plus t by 2. Okay. So this, let me call it as gt of t, any impulse function there. So any function I can represent it. So this one here, it's having an area which would be equal to unity. Okay, so area that would be equal to unity. Now this is the width here. What I'm talking here is this width, what I've represented here is, yes, so this width here represents the width of the unit impulse function. If you want to analyze it in a mathematical way, you can analyze it, and the height would be 1 divided by t. Okay, so now what you can observe in an unit impulse function is so as soon as the width, okay, as soon as the width is getting smaller, the height is increasing. The height is increasing. If you can apply limits for the function, okay, so you'll be getting the unit impulse function where you can define it as limit where t tending to 0 gt of t. Okay, so this is the limit being applied. As soon as the width keeps on decreasing, it is infinitesimally small. Okay, so you can say that the height also keeps on growing there. Okay, so that is where you are going to have at the tip, Okay, at that tip, you are going to have the magnitude which will be equal to 0. So here, when I speak about the magnitude, I'm very much clear about the area of the rectangle, whatever that has been formed here. Okay, so that area, once it has been equal to unity, you are going to get the amplitude of the unit impulse function there. Okay, so that is one thing that you have to keep in mind. Next one is certain properties which are being applied to the unit impulse function, that is the product property. Okay, so we generally call this one to be the product property. I'm going to list out one more property and let me wind up the class. So first one is the product property, and next one is the shifting property. Next one is the shifting property. Okay, so first one is the product property, next one is the shifting property. Fine. Okay. So let me take any function, say phi of t. Any function is there with respect to time, like you will be having sine of t, cos of t, any function which I can generally take it, so that would be termed as phi of t. So once it has been multiplied, okay, so phi of t be any function with respect to time, any function with respect to time. Okay, so then what you can generally call is, then you can call phi of t into delta of t. Okay, so that would be equal to phi of 0 into delta of 0. So only at t is equal to 0, only at t is equal to 0, only at t is equal to 0, you are going to get this value. Okay, so as I already told you, t would be from minus infinity to plus infinity, or any specific duration of time that is being there. So you can have phi of -1 and delta of -1. So okay, what is delta of -1 value? Generally equal to 0, so that would be 0 there, plus phi of 0. Okay, I'm just giving an example where the time limit would be from -1 to +1. So phi of 0 into delta of 0 plus phi of 1 into delta of 1. Okay, so any such values, if I want to find out what is the end result there, so I'll be taking only the value at delta equals 0. Okay, so only the value where delta equal to 0, you are going to get the function's value. So in other cases, it is equal to 0 there. Okay, so in other cases, it is equal to 0. Okay, so this is the term for the product property. Only at phi at 0, you are going to get its value. Okay, whatever the value of the signal that you are going to get, only at t is equal to 0, you are going to get the value there. Fine. So now let me go for the shifting property. It is quite simple. So again, if I want to multiply the signal phi of t, where delta would be changed from t to t naught. Okay, so that will be equal to, I repeat, so these are the standard identities. You can use it as standard identities also, where t would be from t1 to t2, and it is 0 elsewhere. Okay, so 0 elsewhere. So integral t1 to t2 phi of t. Okay, so where delta would be from t being changed to t minus t naught dt, that would be equal to phi of t naught, and 0 where t would be equal to, I mean the range would be equal to t1 to t2, and 0 elsewhere. Okay, so this is one thing. And later on, if you want to calculate the value from minus infinity to plus infinity also, so as I already told you, so that was phi of t delta of t minus t naught dt, that would be equal to phi of t naught. Okay, so only where the impulse is located, I repeat, only where the impulse is located. For example, t minus t naught there. Okay, so this would be somewhat t naught, so you'll be having the value here. Okay, so t plus t naught, if you want to evaluate t plus t naught, okay, so t plus t naught, it would be somewhat around here there. Okay, so yeah, with a arrow mark, that would be equal to 1 there. Fine. So this is one thing that you are going to find it. So the function is being evaluated. Okay, the function phi of t is evaluated only at t naught. Okay, so phi of t naught, the function phi of t is evaluated or it is carried out, any such operation is being carried out when the impulse is located there. Okay, so that is one thing that you have to keep in mind. So now let me come to this problem. Okay, so I'll be able to solve this quite quickly. So I want to find out the first order derivative or the first derivative there. Okay, so differentiating with respect to time, so d by dt, so d by dt of u of t minus d by dt of u of t minus a. Okay, so always remember, once you differentiate with respect to time, okay, so you are going to get the function as delta of t. If you differentiate, okay, if you differentiate, you are going to get delta of t. Conversely, so if you integrate, you will be getting u of t there. Okay, so over a time limit, if you integrate, you are going to get the u of t signal, and this would be again delta of t minus a, where t is being changed from t to t minus a there. Okay, so this would be the first order derivative. So d by dt of x of t. Again, if I want to sketch the signal, that is delta of t. Okay, so delta of t would be from where it would be from 0 to 1. Okay, so now next delta of t minus a. Okay, so delta of t minus a, that would be like this. So yes, with the negative sign, minus 1 into this is a. Okay, so this is minus 1, this is 1 there. Okay, so this is how we are going to get the signal. Okay, so if you are going to add delta of t plus minus 1 into delta of t minus a, you can get the sketch of the signal. Delta of t plus minus 1 into minus 1, that's the reason why I have multiplied minus 1 into delta of t minus a. Okay, so that's how we are going to analyze the signal. Only at that instant, what I told you here was at t is equal to 0, we're going to get other values, we're not going to get that, and minus 1 where t will be equal to a, that is equal to minus 1 there. Fine. So now I'll give you a hint for y of t. You have to use the product rule here. Product rule for derivatives. Okay, product rule for getting the derivatives and sketch. Okay, and sketch. Sinchana, are you there? Sinchana?
Yes, sir.
Yeah,
Yes, sir.
so you can take this problem and do let me know. Okay, how would the derivative would look like and the sketch of it. Okay. Yeah, fine. So we will stop the class right now. Just a moment. Yeah. Only 52 are there. It's not a good sign. Yeah. Okay.